So today we are going to focus on magnetism and then the behavior of magnets towards each other. But the first thing that we need to understand is when we talk about magnets, we talk about the attractiveness of maybe metallic materials towards it. So, and then magnets is represented with the north and the south. So we have the north poles and the south poles. So when we have the north pole and the south poles, we need to understand how this operates and how this works. So between north and the south, we have what you call the unlike poles, and then we have like poles. So unlike poles, they create or they experience what we call an attractive or an attraction force. And then the like poles, they are what we call repulsion force. So unlike poles, they attract each other, and then the like poles, they do not attract each other. So unlike poles, we talk about north with the south, and then the like poles, it can be north and north or south and south. So unlike poles, they are not the same. So unlike means they create an attraction force. So in which is north and south, and then the like poles is repulsion is north and north or south and south. So they create a repulsion force. This one they create an attraction force. So from here we have what we call magnetic field. So we need to understand what is magnetic field. A magnetic field is a region of a space where ferromagnetic materials experiences a force. Ferromagnetic materials, we're talking about any metallic material that can be able to be attracted by the magnet. So all of them, they are neutral, they are either north or south. They can be attracted to the magnet. So looking at this, we can talk about the steel, we can talk about iron and all those. So those ones, they are having, they can experience magnetic field. But remember that a magnetic field is the region of a space, it's a place or it's a location where anything that falls under that particular location will experience this magnetic force. And then the magnetic force, the force that is happening between the magnets, it's what you call non-contact force. The force that is happening between the poles or between the magnets is what you call non-contact forces. So non-contact forces is the force happening or occurring between the magnets. So now looking at this, we have a magnet of this nature, and then we have another magnet of this nature, where now we can say that we have south, we have north, we have south, we have north. So looking at this, now this is a bar magnet, this is a bar magnet. So as long as this is a bar magnet, this is a bar magnet. Something that you need to understand is, as long as here is south, here is north. If I were to take this magnet and split it into two parts, the magnet will create another south, and then the magnet will create another north, so that it can still operate the same way as it used to. So these ones, we call them permanent magnets. We call them permanent magnets. If I were to break this into two parts, I'm still going to have the north and the south. The other part where I did the cutting, it will create the different poles from the other side. Even if I do on this one, it will still operate the same way. So these bar magnets, we call them permanent magnets, where even if you break it, it will still create a new poles for it to attract materials toward itself. So, and then now the non-contact is the force that is happening here. The force that is happening here is what we call non-contact. If I were to join or to merge this together, then the force that is going to be happening is a non-contact. That's why they get too close to each other. So now when we talk about magnets, that's what we talk about. And then now you need to understand what we call magnetic field lines. Magnetic field lines are the lines that gives the direction of a magnetic field. So magnetic field lines are the lines used to give the direction of magnetic field. So example, if the north and the south are on the same side, they will have an attraction. They will have an attraction where the north will always be attracted to the south, and then others will also operate the same way. But remember that the electric field lines for north are always going out within arrows, and then the magnetic field lines for the south are always going towards the south. So if you look at this, the magnetic field lines are moving from north going to south. Even if it's still alone like this one, if I were to draw electric field lines, it will still be in this fashion. So these arrows, they indicate the direction that I'm going to, or I'm using the direction of magnetic field lines. And then now I'm going to south, in which it can connect with the south. So as permanent magnets, how they operate, this is how they operate, permanent magnets. And then we have the north and the south. Because these ones are unlike terms, they attract each other. The attraction is the connection here, or the type of attraction here is an attraction, right? So this is what is going on here. And then another part is that when we talk about north and the north, let's say it's north and the north. North and the north, they will do what we call repulsion. Another thing is, the electric field lines should never cross each other. Electric field lines, they should never cross each other. Why they don't cross is because they are parallel to each other. Electric field lines, they never cross. That's the first statement, or the first understanding you need to know about this. Electric field lines are stronger where they are closer to each other. So where you see electric field lines packed to each other or closer to each other, that's why electric field strength is very strong there. So the further you go away from, the further they go away from the magnets, the weaker they become, and then the closer they get to the magnets, the stronger they become. So electric field strength is strong where the electric field lines are packed close to each other. So this is the interpretation of magnetism, and then looking at everything that you will be doing, I wish you that you will understand what is going on in terms of magnetism, and then you can do best out of them. So